Hi. So if you were just thinking about the plan for the rest of your day and you were thinking, what could I do that would make my day just a little bit more fun and a little bit better? And calculus was on your list. Don't worry, here it is. You get to do that right now. And if it wasn't on your list already, I hope it's one of those like wonderful surprises that comes out of nowhere. Where like, what? I get to do this thing right now. We are only going to do 2 pages. And yes, you get to learn another rule for differentiation for taking the derivative. And it's going to involve exponential functions, so e raised to some power, and natural logs and other things, but it's actually not so bad at all. So let's do this. The first one, so if I have a natural exponential function, so if u is a differentiable function, and then we have the derivative of e raised to a u, and this says e to the u times du dx. What I'm going to say is the derivative of e to the anything is going to be e to the anything. So whatever that power is, you just write it down again, times the derivative of the anything. So I'm going to say anything prime. This du dx takes the chain rule into account. So like if this were e raised to the 5x, you would just say times 5 over here. It does the chain rule for you. So it's kind of reminding you every time. So to do the chain rule. So for instance, e to the sine of x power. This would be f prime. So the derivative of e to the anything is e to the anything. So in this case, e to the sine of x times the derivative of the anything. The derivative of sine is cosine. No, I am not making this up. That's it. This is all there is to this. So e to the sine of x times cosine of x. And then you're done. Let's do another one. How about you try this one? If I do, this is e to the 2x plus 3, e to the anything times the derivative of the anything. You try. E to the 2x plus 3 times 2. If you wanted to, you could write 2e to the 2x plus 3. Or I can just leave like this. Okay, does it get worse? Not really. We might get to do some other things that we did before, but this is it for just e to the anything. So f prime of x, this is 3e to the 2x. A coefficient, we just keep along for the ride. So I can just write 3e to the 2x, so e to the anything, coefficient just stays, times the derivative of the anything. So if you really wanted to, and you're like, I want to write the 6e to the 2x, you go for it. Okay, but you're saying, now here's where it gets hard, right? In this particular problem, I have the product rule. What is the product rule again? First times the derivative of the second plus second derivative of the first. So I'm saying first derivative of the second. So the second is an e to the something power, so e to the anything, times the derivative of the anything. So first derivative of the second plus the second times the derivative of the first. And that's it. Nice, right? What about this one? F prime of 2x, or f prime of x would be, this is a product rule again. So first, the derivative of the second plus the second times the derivative of the first. And then that's it. There are some problems somewhere where if you have like e to the 2x, you see how it's in both terms. If you wanted to simplify this, you could take f prime of x and you could factor out an e to the 2x. So then this would become 2x squared plus 2x. And you could actually, from here, factor this out and say, you know what, I want to take a 2x out of both terms. So I could still rewrite things in different forms, but this is the derivative. All the rest of this is just simplifying, just algebra. Okay, what about this one? Well, I see something crazy going on anyway. There's a square root, which I always want to rewrite as something to the 1/2 power. So I'm going to rewrite this. And then I'm going to say, well, that looks like a function within a function. Wow. That's the chain rule. So what I want you to do is take, what is the chain rule again? Take the derivative of the outside. So this is where the 1/2, the negative 1/2 is coming from. What do you do to the inside? Leave it alone. Times the derivative of the inside. E to the anything is e to the anything times the derivative of the anything. The derivative of the exponent in this case is just 2. I want to simplify just a little bit because I don't want a negative exponent. 2 times 1/2 would just cancel out. The e to the 2x minus 6 would stay in the numerator. E to the 2x minus 6 to the 1/2 power would go in the denominator. And then here's where it's just fun to keep going a little bit. See how this is raised to the first power? If you have anything that has the like basis, so x squared divided by x, for instance, x squared divided by x, you might be able to write that out and be like, well, that's like x times x over x. You cross the one out, and you can say this is just x. The other way that we can say this is these have the same basis, so I can subtract 2 minus 1, which is be x to the first power. So right here, if I've got the same base, e to the 2x minus 6 to the first power, same base in the denominator to the 1/2, you can subtract the exponents. Say e to the 2x minus 6 to the 1/2 power. And you might be thinking, isn't that the same thing as square root of e to x minus 6? And then one more second, see what's happening here. Yes, the function is square root of e to the 2x minus 6. And the derivative is the square root of e to the 2x minus 6. Also, fun fact, if I have another function down here, let's say e to the x, what's the derivative of e to the x? E to the anything times the derivative of the anything. The derivative of the anything would just be 1. Hey, it's the same thing. Okay, so were you thinking, I hope I can do another one, maybe involving the quotient rule? I just like to give people what they want. So when they see, like, when they say in their minds, probably that's why you're saying it right now, but you're like, I really just want one to also do the quotient rule. Here it is. What is the quotient rule again? Bottom times the derivative of the top. E to the 5x times 5, e to the anything times the derivative of the anything, minus top, derivative of the bottom. Derivative of 3x squared is 6x over the bottom squared. Ta-da! Do we want to simplify this anymore? I did before. Yeah, I can do it again. So maybe in this one, I know in the denominator I've got 9x to the 4th because I'm taking 3 squared, x squared squared. In the numerator, I want to see, do I have any like terms? I have an e to the 5x in both. I've got an x in both and a, yeah, x in both and a 3, I can say, because this would be 3 times 5 is 15. So I can take a 3x e to the 5x. If I do that, I'd be left with 1x here, once I factored out a 3x, and a 5 over here. Over here, e to the 5x would be factored out, and x would be factored out. 6 divided by 3 is 2. This is the derivative. This is just me simplifying a little bit, but if you want to leave it like this, you can. If we did exponential functions, we might as well do natural logs, and this one's actually not so bad either. If u is a differentiable function of x, and u is greater than 0, the only reason why this is in here is because you can't take the natural log of 0 or a negative number. So I want u to be greater than 0, meaning the natural log of, this is the derivative of the natural log of u, is 1 over u times du dx. Or I can say the derivative of the natural log of anything is 1 over anything times the derivative of the anything. And yes, this one really just already takes into account the chain rule. So you don't even have to remember that it's part of this, like 1 over the anything times the derivative of the anything, because it would be really easy to forget the chain rule on some of these. So this one, I've got f prime of x would be 1 over the anything. So it's just 1 over the inside times the derivative of the inside. If you wanted to put the 2 in the numerator, you go right ahead. If you want to leave it like this, you do that. You try this one. 1 over the anything times the derivative of the anything. This would be 6x plus 2. If you wrote it like that, though, there's a mistake. Fixed it. And if you want to put 6x plus 2 in the numerator, you don't even need the parentheses then, because then they're implied. Okay, there's another one. This one's exciting. It looks like there's a function within a function, but really all of these are, because all of these would be natural log of x. So I could be saying wow on all of these, but cosine seems particularly fun. I would have 1 over the anything, so 1 over cosine. Whew, what am I thinking? Labeled this. 1 over the anything times the derivative of the anything. The derivative of cosine is negative sine, which if I wrote negative sine of x over cosine of x, this one really seems like I just should simplify. Negative sine over cosine, or sine over cosine, is just tangent of x. Negative because negative divided by positive is negative. Okay, this last one, anytime I see a natural log, but I see something raised to the 1/2 power. Be careful how you write this, though. This would be the square root of 2x minus 4 if it's raised to the 1/2 power. So you're taking the natural log of something raised to the 1/2 power. You're not taking the 1/2 of everything. It's not the square root of a natural log of a number. So here I can see a function, and it's actually within a function. Yes. F prime of x is equal to 1 over the anything, so 2x minus 4 is the 1/2, times the derivative of the anything. So when you do this, you've got the chain rule. Wow. Take the derivative of the outside. So I did the 1/2 to negative 1/2. I left the inside alone, times the derivative of the inside. These 2's cancel out. One more thing. This would be 1 over 2x minus 4 to the 1/2. This was negative 1/2 as an exponent, so I'm going to put that in the denominator also. Remember, when you're putting something together, when you've got like bases and you're multiplying, you can add the exponents together. It's like this. X times x is the same thing as x squared. I'm adding the exponents together. Here I've got 2x minus 4 to the 1/2, 2x minus 4 to the 1/2. That's my like base of 2x minus 4. I add the exponents and I would just get 1. So you have 1 over 2x minus 4. And that's it. We did it. So you should be thinking, what is the product rule? The product rule is first times the derivative of the second, plus second times the derivative of the first. What's the quotient rule? Bottom times the derivative of the top minus top derivative of the bottom over the bottom squared. What is the chain rule? Wow. Take the derivative of the outside, leave the inside alone, times the derivative of the inside. What is the rule for whenever you're doing with exponential functions? E to the anything times the derivative of the anything. Natural logs, 1 over anything times the derivative of the anything. And I think you had it. It's just really practicing with all these things over and over and over again until you become really good at them. There are a few more rules, but these are the big ones. Thanks so much. Have a great day. Let me know if you need help on anything. I appreciate you, and I'm super thankful to teach you. Bye.